Hey guys, it's me. I'm back, and I'm going to kind of take you through a journey, or I'm hoping to take you through a journey of something that I recently, I guess, stumbled upon or kind of have been thinking of, and I kind of wanted to just kind of shoot this towards whatever science community there is here on these social media platforms. But I kind of have like a new theory about the creation of the universe, and I don't want to get into creationism versus like atheism, but it's just more or less trying to stick to just certain kind of scientific facts, and then maybe at a later date in time we can start to discuss, more philosophical implications or anything else like that. That's fine. I think that's also needed just because those are the things people think about, and it's fine to think about them. But I'm trying to keep this kind of more along the lines of just refuting the Big Bang Theory, just because I think ultimately, and I always have for a long time, just thought it was a bunch of bullshit. Like, to me, the Big Bang Theory is for scientists what just God and creationism is to a lot of religions. It's just there isn't really any foundations for it. There's nothing experimental or evidence of in the universe for it, and everything just kind of contradicts it, especially with a lot of the stuff coming out of the James Webb Telescope. It's just almost laughable at this point. So there's another theory that's out there. It's the CCC, or the Conformal Cyclic Cosmology by Penrose. Once I stumbled upon that was only recent. That was just like maybe within the last 5 years. I was just like, oh my god, and I got absorbed in it. I bought a few of his books, read through some of them. I mostly just stick to lectures about it online and from himself, just to kind of get the basic concepts and theories of it. And I was just like, this is kind of more for me. Like, this makes sense that the universe would just kind of repeat itself, right? It would go through these phases of expansion and then phases of retraction, and it would just kind of do this indefinitely. And that makes sense to me, right? I think we'll always have struggles with explaining the cosmic radiation background. I really don't think that there's any good science to explain it. I hope that what I'm going to put forward kind of does, but I can just give you a brief rundown of why the Big Bang Theory just doesn't, right? In terms of just like the classical Big Bang Theory, I remember being taught this in school, and my parents were against it because they're like huge creationists, but even myself, I was just like, that is dumb and it doesn't make any sense. Like, to me, it just never made sense. Like there wasn't just this, implosion of all matter into this tiny little, like, golf-sized ball that just exploded. Because one thing, it just doesn't say, well, where did all that matter come from? What was it before? It still implies that there was a universe before, which just kind of all plays into CCC anyway. And you also have to think about it. If there's like some point that everything kind of exploded from, we definitely at this point would be able to take all the galactic observations and say, like, yeah, this is the point at which all things are spreading from, which doesn't exist because things are expanding from each other uniformly all over the place, meaning that there isn't one point that things are expanding from. Things are just expanding from each other in general. Like, it's a really weird concept, but mathematically that's just what's going on. And then you have things like the Great Attractor, which also is a contradiction to any kind of like classical Big Bang Theory. And then there's also like I would just say like any kind of like quasar, pulsar, magnetar, and black holes, just also like proof that that's not how things would work. Because what big masses and of like objects with big masses, they like to just have these huge jet streams of plasma and matter, like, just burst from them, like huge jet streams. Like, there was like the largest one. I would love to, like, I was going to do this. I was going to sit there and like see how much mass they would calculate, and the one that was just recently found was like just like mind-blowingly like huge jet streams that they can't comprehend. I think I forget if it was like 400 million light years across or something like that. I don't remember. That's probably not the right number. I can't remember at the top of my head. I just know it was like massive. But that's just kind of proof that like if you start to clump in all this highly dense mass, it doesn't actually want to stay like that. You're going to have these huge jet streams come out. So like let's say that there was some kind of event, some kind of gravitational event that started pulling all the mass in the universe together to form this. It's going to immediately start creating these like jet streams and pulses, and it's not going to want to stay there, and essentially it would just kind of reset the universe and put all of this matter back out there, right? So that in and of itself kind of, I think, would prove that that's just not a possibility, that matter does not want to stay clumped together like that. And there's nothing in the observable universe that would state that that's how things would go down, like outside of just maybe like, well, I wouldn't even say stars do that, because stars have accretion disks and things like that, so even they can't even keep their own mass together. That's just not how things work in the universe. So like nothing that we've observed that would give rise to that. And then plus, if you have like, the one thing I just absolutely hate with the Big Bang Theory is that even with the the cosmic microwave background, you have like all of that coming at us from every single direction, right? And this is like light, so to speak, that is so ancient that it eventually kind of decayed into radio waves, which is understandable that scientifically could be possible, but it's coming at us from every single direction. So you're saying that like all the light from the beginning of the universe has already like bounced back to us from extremely long distances that we can't barely even calculate, and then all of a sudden it's like radio waves and it's coming back to us. Because even if that were true, that would put the universe way, way older than what we're stating it is. And then, I've talked to people who are like, oh, no, it's just because, like, it's no longer like the Big Bang, but it's like the Big Bang because it kind of is like one, but, all, like, there's a bunch of hydrogen and everything just kind of, like, started to phase in to the universe. And I'm like, that's kind of like what a lot of CCC is, I guess. That's kind of some of the ideas around it. Because people are trying to make sense of basically nonsense, right? It's just a bunch of mathematical nonsense that doesn't describe anything in the universe. All math is good, right? Because, I think, recently was reading a book, Lost in Math. I don't know why I spaced it on that. It was like Lost in Math. And, she makes a really good point of, math can't lie. And that's true. Right, math doesn't lie, but mathematicians do lie, and mathematicians sometimes fail to be able to comprehend what their math, implies. But on that note, so what I'm putting forward is just a new concept about how the universe kind of came about. And once again, I still don't think we know enough about the universe to state one way or the other where it came from, right? So like you can, I'm just putting a proposition down based off of how the universe functions as it is today, that we probably could prove that it would function that way. But in terms of where all of the mass comes from, I don't think we're there yet. Just to be honest, like we're not there yet. Like there's nothing to, and I don't think we can, just because it's just too big for us to observe. At least now, like maybe in the future, I think it's a possibility, but like we just don't know enough, and we haven't observed enough, and we haven't really put forward the best explanations yet. Right, those are to come. I think we are on that road. I think there's a lot of great discoveries being made today, and there's a lot of great math and science being done. But it's not perfect. If you're not challenging yourself, if you're not challenging other people, then you're left with a big pile of shit most of the time, right? So you kind of have to. You kind of have to challenge people. Otherwise, breakthroughs don't happen. People get complacent. So you kind of have to put that pressure on. So I try to put that pressure on myself to kind of just like, what would make the most sense to me, and could you actually back this up with validatable science? And so I think I did that. So what I'm putting forward is called, just for lack of better terminology, is called CCEC, so Cyclic Crystalline Expansion Cosmology. And it doesn't mean it has to stay that way. Someone else can feel free to come in and swoop my work up and then take it over and call it something else. I don't care. I'm just trying to advance the concepts in these fields, right? This is something I thought about for a long time of my life. Like, probably, when I was walking home from work and I had like a mile-long walk I gotta do, this is what I was thinking of. Whenever I had to take a 2-hour bus ride somewhere and I was reading like, Maxwell or Planck, this is kind of the stuff that I was thinking of. So let me get into exactly like how I think the beginning of the universe kind of worked, right? So you have hydrogen gas, and I think we can all conclude that like the foundations of the universe, as at least we know them, probably was just a bunch of hydrogen gas, because like most atoms will want to decay into hydrogen, and most subatomic particles will want to create hydrogen, right? It's kind of like an equilibrium within like the known fields, force fields and potential fields that we can define. It's just matter just kind of wants to structure itself as hydrogen, and that's cool. And I think for a large part that's understood and that's agreed upon. So we could kind of conclude that if there was some kind of like quote unquote beginning, it would have, at some point would have existed as, subatomic particles or matter or whatever, forming extremely large amounts of hydrogen. And this probably happened over like trillions of years. What it was before, I wouldn't be able to say. And I'm not saying that I know what it was before, or am I hypothesizing or theorizing what it was before. I'm just stating that let's just start there, right, as a starting point. And then, maybe in the future, someone else or myself can like maybe come up with something clever and maybe figure out like what it may have been before. So you have to kind of think about like what would a bunch of hydrogen out in space that hasn't been anything yet, what would it become? So obviously, this is just a known fact that individual atoms have their own gravitational force. Quantum mechanics or quantum field theory, as far as I understand, can't actually account for individual atoms having gravity. There's no like quantum function that shows gravity should exist. I know we're working on it, gravitrons, whatever you want to call it, but we know that they do. Experimentally, we can prove that individual atoms have gravity, and yeah, I'm not really too sure. I guess I would need to do more work on that. I'm not too sure if like, it's additive. Like if you have two atoms together, the gravitational pull of both of them would be additive, or if it's like multiplicative. But I mean, that's just kind of how it is. So you would have gravity at the beginning of the universe. So eventually they would all start to kind of, the hydrogen would start congregating, right? Because it's a continuum. All matter functions this way. Even in vacuums of space, they want to stay together, right? That's just the fact. So it would start, causing gravitational fields. The matter would start to accumulate on itself, and so this is kind of where the uniqueness comes into my approach to it all, because so hydrogen can form crystals under extreme pressure or under extreme coldness, right? So whenever it's super cold, and these crystals form essentially what you could call like a hexagonal crystal formation, and it kind of, you can get hydrogen into what's called a solid state, right? So this is where it becomes like so cold or so pressurized, or it becomes like solid, and it would become crystalline. So this happens whenever it is at negative 259 degrees Celsius. Now space is, on average about negative 270 degrees Celsius. So you know that space would be cold enough to turn all of that hydrogen into a solid state crystal, right? Or like in that form. So whenever you have a whole bunch of it that's congregating over trillions of years, what I think would happen is that you would have an actual crystalline structure. It would be kind of like a pillar of hydrogen. Like it would actually start to just self propagate as a crystal form in space, because it would be so cold, and with all the gravitational force from itself, there would be pressure, especially on the inside. It would be highly pressurized, and then as you go out, less and less pressure, but you would have this huge hydrogen kind of crystal, or like pillar. That's what I like to call them, just like a pillar of hydrogen, of solid state hydrogen. So I think that there would be kind of layered too. So in the center, it would be in kind of like a quantum state almost. I don't want to say like quantum state, but it would be kind of like in a phase space where it's not necessarily like a gas or solid, but it would be kind of like a gas that's in a solid state. Just because there would be so much pressure there, it wouldn't be able to like be fully capable of being like crystallized. But as you kind of go out, it would slowly kind of there'd be like a gradient where it would start to become a really thick crystallized solid state structure. And then after you kind of get out of that, because there would be less and less pressure on all the hydrogen on the outside of this pillar, it would then kind of just be kind of more gaseous, right, as you get out the outside. So you'd have this like gaseous ring around the pillar, then you'd kind of have like this crust of like actual solid state crystalline hydrogen. And as you get into the center, just because it would be like hotter, so to speak, it's gonna be like this gaseous kind of crystalline state. And from there, though, because that's just like the basic structure of it, right? So whenever you kind of have these strong gravitational forces, you would start to have, electromagnetic fields be created, right? And this is kind of where it starts to get into, okay, well, you have this big crystalline structure. How does that turn into a universe, right? Like, how do you start generating a universe from that? So you would have these like large gravitational fields that would kind of cause the electrons to become kind of, excited, right? And they would kind of become into like a kind of a cold plasma state. And this is kind of where like the huge thing kind of comes in, where you have like this really large hydrogen crystal, right, pillar, like crystal hydrogen pillar, but it not only would it be in like this like extremely cold solid state, but it would also be in a cold plasma state where the electrons are like super energized, but it's so cold that the amount of energy that they're dumping out into the rest of the atom is negated by how this cold the empty space is. This isn't like, this is kind of what I call like a fluffy gravity. Like, I don't know if that makes sense, but it's not like there's not like enough gravitational force to start fusing the atoms together, so it's not like a star or anything. So none of that's happening. So it's kind of like a soft, fluffy gravity, right? And it's just like enough to start creating electromagnetic fields. It's strong enough to really have like a really strong gravitational field, but there isn't any dense atoms yet because it's just hydrogen. So you don't really start having like those phenomena that happen in like stars or like black holes, where it's like extreme pressures and extreme conditions like that. But whenever you you have like that strong magnetic field, what will happen to electrons? And I feel like this could probably still happen in an atom itself, right? Because you have like that circular revolution around the nucleus. You would start to have what's called synchrotron radiation start to happen, where the electrons are like super excited. They're in this cold plasma state. They don't really have the ability to efficiently dump their energy, creating like a kinetic energy inside the atom. So they're like in this supercharged state, and they're just like going around and they're going crazy around the nucleus, and they're going like faster and faster. And as time goes on, the gravitational force, everything's slowly shrinking in over like billions and trillions of years, to the point where that synchrotron radiation or energy becomes strong enough to where the electrons will start to emit gamma rays, and will start to create microwave radiation. And at some point, these forces will become strong enough to overcome the binding energy of the hydrogen atom, which I think it's like equals to 13.606 eV over n squared or something. I'm not really good at these numbers. So, but that's kind of what it is. That's kind of like what the binding energy of hydrogen is. And I think you could probably calculate a lot of this stuff. I haven't done like the hardcore calculations but that's kind of why I'm trying to present it, because like I'm trying to like bounce this idea off of people, like, hey, this seems like it would actually be kind of possible, right? And I'm still developing it more, so just kind of stay with me. But essentially what would happen is that gamma rays and microwaves can knock electrons out of their orbits, out of their atoms, right? So whenever you have the synchrotron radiation gets strong enough to the point where it can overcome the binding energy of an electron from a hydrogen atom, and it can knock an electron out, you then have this like kind of free roaming electron. And once it's highly energetic, right? And then once that slams into the nucleus of another hydrogen atom, it will dump all of its energy out into that atom, and it's going to become kinetic energy, and it's going to heat it up a lot. The thing is that I guess this is where it kind of gets weird, that all electrons are entangled as long as they're in the vicinity of each other, right? So you're going to have this highly dense hydrogen. So there's going to be a lot, right? And so you potentially would have kind of like a chain effect where, because an electron dumped all of its energy into the nucleus of a hydrogen atom, that you may just have a chain reaction of all these electrons doing the same thing. If you don't have that happening, at least you would have enough gamma radiation and microwave radiation that would be knocking other electrons out too. So this doesn't necessarily have to be something that happens at like a singularity, right? Because there would be just like one spot where this is going to start happening first, and that's the beginning of the universe, right? As we understand it. Because what happens whenever that electron dumps all of its energy out as kinetic energy into the nucleus of a hydrogen atom, it's going to start to boil, right? Because the crystalline structure in the solid state is right there at like the temperature for hydrogen to be in that solid state, right? And it's going to heat it up past that, definitely. And it's going to do like a flash boil, because that's like one of the properties of hydrogen, is that it flash boils. Like it becomes gas very, very fast. While you can get it into like a liquid state, the amount of energy there and like the amount of time it takes for it to boil, it's going to almost become instant. It will be what's called sublimation, right? So when you have dry ice and you put it in normal room temperature, it just instantly becomes CO2 again, right? There's no water phase, and that's what's going to happen. And this boiling point is just going to cause like a chain reaction of heating up all the other, if the electrons don't do it themselves, just this, boiling of even just like one atom into like it's back to a gaseous form is going to be enough kinetic energy to start heating up all the other hydrogen atoms around it. It's already like super compact, so you're just going to have this huge chain reaction. And like I said, it's probably not just going to be like one singular point, even if it starts at one singular point. I don't know, maybe like 500 million light years away. That's happening over here too, but it'll reach that kind of boundary condition where it will just start happening like all at one time. Even if it's not exactly at one point, there will probably be an area within this crystalline structure that this will all start kind of happening around. But this boiling of all the hydrogen, what I'm hypothesizing is the backbone of like the cosmic web, because we know that the cosmic web is essentially like the universe, right? Like we know that all galaxies and everything exist inside this cosmic web. I believe it's like a lot of gamma radiation. I think I could be wrong, but I think like the James Webb Telescope was able to see it within normal light. I think that's kind of what's happening. It's just like a lot of this, cold plasma hydrogen still within the cosmic web, because that's what's essentially it's made out of. And I was gonna make a photo of some of this stuff in Photoshop, but I got kind of lazy and didn't. I kind of just wanted to be like, oh, it's gonna be too much work for this video, so I'll just talk about it, and then hopefully, if people want to hear more or see more like examples or pictures based off of it, that could be cool too. I can do that here in the future. That way, for more visual learners, you can kind of see it. Like what you would have is once you start to have the hydrogen creating like this web-like structures, it's all expanding from each other, but that expansion is kind of I guess incongruence with just like the boiling of this highly dense and pressurized gas, right? So it does account for all the heat in the beginning of the universe, because you're gonna have like these extremely energetic electrons dumping all of their energy into the nucleus of the hydrogen atoms. It's going to massively heat them up to the point that we see in the beginning of the universe. And then we can account for the expansion is just what happens to a solid when it becomes a gas. Well, it expands. It's pretty much that simple. When I was thinking about it, I was like, no, it can't be that simple, but I think it kind of can, where the expansion of the universe is literally just like, it's analogous to dry ice, turning into gas in room temperature, right? Like it's literally just expanding gas. And that's what's causing all the heat and all the expansion we see at the beginning of the universe, and it's going to be pretty chaotic, but it still explains it, because we know that it's just a bunch of hydrogen that eventually starts to develop galaxies, things like that pretty early on. But it's all connected still, right? Because you have like this funneling off of the crystalline structure back into gas, and that feeds into the cosmic web. I wouldn't be able to fully explain the cosmic web. The mathematics don't really exist for it, at least not that I know of yet, but that's just kind of, on my understanding, it would make sense that the structures would start being created whenever you have that, just from a standpoint of just like gravitational forces and magnetic forces. It's going to want to keep in like into a continuum, like all matter does. It wants to stick together in a vacuum. It's not just going to spread apart and go everywhere. Like that's just not how matter works. It's in a certain way aware, and it's just like, hey, you're matter, okay, well I want to stick to you. I don't want to go off here in empty space by myself. Not to say that it has intelligence like that, or like a consciousness, but that's just kind of metaphorically like how I kind of like to think about it. And so it creates this cosmic web superstructure. And then eventually, right, so this is kind of where we start to get into the cyclical part about all of it, is that eventually it expands, right? It kind of, I don't know. I like to think like the pillar is about how I imagine it, and like my basic mathematics would put it is just it would be somewhere around the 4 times the amount of known mass of like the observable universe. Like let's just use that as a baseline. So you have this is our universe and it's so much mass, and then the whole of the universe, right, that pillar, which would still be part of our universe, right, is about like 4 times what we would normally attribute to like our known universe. And that would make the most sense to me in terms of like this being feasible. So, but once you start having the expansion and like, it's going to be spherical, right? Just because, that's just kind of how things want to work out. So you're either going to be like spiral or, circle. We kind of know it goes, just from observation, that it kind of goes almost unlimitedly in every direction. So I wouldn't say that there's even a boundary condition to like this bubble, so to speak, that is created, but it's just like this bubble of expanding cosmic web that's creating all of the galaxies and everything else in it. And it's like making all the hydrogen more dense through star formation and supernova and all of that good stuff. Our universe is becoming more dense, and as it reaches a certain point, it is also becoming more and more hot, because you have like the boiling of all this matter and like creation of stars. Like that's gonna heat things up. I definitely believe that energy can be created in terms of mechanical senses. In terms of just like normal atomic bodies, no, but in terms of like quantum functions and just anomalies, yes, like their energy can be created and destroyed. So you have like this creation of a whole bunch of energy which heats up the universe, but at a certain point, like whenever the that bubble gets bigger than the crystalline structure, it starts to go out of the bounds of that, like I said, that gaseous outside ring. Once it starts getting past that, it starts to cool down, right? It starts to cool down because there's nothing protecting it from like the cold, so to speak, right? It's back to like just touching absolute like empty space again. Although I don't think it would be empty, but like there'd still be like gravitational fields, things like that, electromagnetic fields, but you know what I mean. Like it's empty space. It's going to be super cold, so it's going to start cooling things back down. And at this point in the universe too, you have everything's becoming black holes, right? And so it's already breaking down all of the super dense atomic structures. Over time, things tend, like I said, they want to turn back into hydrogen, and so you have everything kind of becoming more basic again as the older it gets. It's kind of like a baby, right? You're a baby, you're young, you don't know nothing, you get in your prime, you're strong, you're fit, and then when you're old, you're almost like a baby again, you can't remember anything, can't walk, poop your diaper, right? It's the same thing. So it kind of starts getting to the state where it's starting to kind of revert back into a whole bunch of hydrogen, and of Penrose's theories are right. You have all the information being reset, like the atomic structures, all this information's being lost through like black hole radiation. So it starts to shrink on itself, right? So it starts to retract. So it's no longer expanding, it's retracting, it's becoming colder, it's becoming more primal, it's becoming just a bunch of hydrogen again. And I don't know if there would be like some point where it completely collapses, maybe for like a second, but whether it's after or right before, you would have the function start over, except most likely at a different point in the crystalline structure, because it wouldn't be able to happen in the same point. So think of it like the first anomaly happens where, you know, the universe creation happens in the middle of that crystal, and then you know, that it expands, it goes back in, but still a little bit too like hot for all the same functions to kind of start happening again. So maybe not in the middle, but maybe like, you know, 2/3 down, it happens there, and it kind of does that eternally, right? Because we haven't really proved that there's a beginning or end to physical space-time, guys. Let's just be honest, we haven't. There's nothing that states that. I'm never gonna believe it. But yeah, we can get into that in another video, because I do actually want to talk about physical space-time at some point, because I do have my own unique views on that also, and that all kind of ties into kind of more like spiritual stuff also, but not necessarily. So like I said, I'm trying to keep all of that stuff out of this video. So that's kind of it. That's my idea. I guess I went through everything. I try to take tons of notes. So I think that it's pretty solid. I think you could conclude that based off of the science and just how we know things to work, that it would be feasible that, you know, that the universe is realistically just like one big crystalline superstructure of hydrogen, and that our known universe is like the boiling off of that hydrogen inside of it because of certain like a singularity event that happens, that's repeatable. It just closes back up, becomes a full crystalline structure again, another one, you know, starts happening, another singularity happens, it expands, cools down, shrinks, and it just happens again and again. And then that's kind of what the cosmic background radiation is just, it is that crystal structure that is, the light from it is finally getting to us, right? Or like the microwave radiation from all of it is finally getting to us. And that would make sense to me. Whether that makes sense to you, I don't know. This video definitely went on way longer than I thought it was going to. I really didn't mean to try and explain all of this in that time, but I also just kind of wanted to like end on one note, and just because I was kind of digging through a bunch of old books of mine, just to see if I can get any reference material that could kind of help me like articulate a lot of this stuff maybe better. And I ran into this George Cantor, really awesome guy. You know, this one in particular was on like transfinite numbers, and I think this is like this little tidbit. I'm just gonna read to you from it. But I haven't read this in like 10 years, and I was digging through all my old books, and I was just like, yeah, I'm gonna read that right now. Oh, I was reading a bunch of Leibniz too, but this week, just to kind of get ideas going again. But in this little introduction to his book, this guy who did the introduction to this book is amazing. His name is like Philip Jourdain, and yeah, I mean, he just clarifies transfinite numbers so well, probably better than and explains them probably better than, you know, Cantor did in his writings. But I just want to read this and then like kind of leave like a concluding note here. But it says, thus, from the new point of view gained, we get new insight into the theory of finite number, as Cantor put it. The conception of number, which in finito has only the background of a numeral, splits, in a manner of speaking. When we raise ourselves to the infinite in the two conceptions of power and innumerable, and when I again descend to the finite, I see just as clearly and beautifully how these two conceptions again unite to form that of the finite integer. So the only reason I bring that up is just because I know I kind of played around, you know, I think with my last video saying that, oh, it's like I'm making this infinite, you know, battery, which isn't necessarily like wrong, but nothing in the universe is really infinite, but yet it's transfinite, and that's something that kind of Riemann made the point of, is that, and this is kind of the basis of all quantum mechanics, is that, you know, everything on the smallest level is you know, is one half finite, one half, you know, kind of infinite, or always going towards an infinite. And that's kind of what the transcendental is in mathematics too, is, you know, but just by definition, whenever you have something that's finite or innumerable, and it starts to become infinite, then it's in this stage that we call transfinite, right? It's transitioning into an infinite. So where we see that with atomic structures is, you know, with quantum like weirdness, right? So things are these you know, particle wave functions. So the particle would be the finite nature of it. It's something tangible, it's something we can kind of see and interact with. But these wave functions we really can't, and they almost do come into the realm of like the infinite, because, you know, whenever that particle is collapsed, it could be at any point at, you know, within that field, and it's almost, there's like an infinite amount of possibilities, but there isn't, right? And that was something that was recently proven, like, you know, Schrodinger was proven correct, that you can actually guess and know where a particle is going to be whenever it collapses inside of its field. But that's besides the point. But what it means is that even in terms of like just general reality, that, you know, the universe and its functions are this like interplay between infinite functions and finite functions, and that they are constantly transitioning into the finite is always transitioning into the infinite, and the infinite is always transitioning into the finite. But it's really neither both, right? Because as Riemann kind of clarified, that, you know, it is finite yet unlimited, which is transcendental in itself. I don't know, it's kind of weird stuff, but I just thought I would leave it there. That's the nature of the universe. It's transfinite, and it's not necessarily infinite either. When we're finite, it's somewhere in between both. That's what particle wave functions are, and yeah. I didn't really know how to end this video, but if you liked it and you stayed towards the end, that's fucking awesome. Just leave a like, leave a comment. If you have any questions, throw them down there. Like I said, I'm not stating that this is how the universe works. I'm just putting it as like a potential theory. It's the only thing that's ever made sense to me in my life about how the universe could function, even just going through all the math, or I should say all the bullshit that would state that it's like, you know, CCEC or you know, a Big Bang. This makes more sense to me, even though it probably is going to make me seem crazy talking about it. You know, think about all the people who thought the Big Bang was crazy when people it first kind of came out, and the mathematics were trying to demonstrate that it could be true. I still think it is crazy. I think it's like old school flat earth kind of crazy, but yeah, no, boomers be boomers. But yeah, like I said, leave a like.